Chapter 11. Chapter 11. Oh my goodness. Infinite sequences and series. Betelgeuse is a red supergiant star, one of the largest and brightest in the observable stars. In the project on page 783, you're asked to compare the radiation emitted by Betelgeuse with that of other stars. Infinite sequences and series were briefly introduced briefly in a preview of calculus in connection with Zeno's paradoxes and the decimal representation of numbers. The importance in calculus stems from Newton's idea of representing functions as sums of infinite series. For instance, in finding areas, he often integrated a function by expressing it as a series and then integrating each term of the series. We will pursue his idea in section 11.10 in order to integrate such functions as e of negative x squared. Recall that we have previously been unable to do this. Many of the functions that arise in mathematical physics and chemistry, such as Bessel functions, are defined as sums of series, so it is important to be familiar with the basic concepts of convergence of infinite sequences and series. Physicists also use series in another way, and we will see in section 11.11 in studying fields as diverse as optics, special relativity, and electromagnetism. They analyze phenomena by replacing a function with the first few terms in the series that represents it. Section 11.1 Sequences. A sequence can be thought of as a list of numbers written in a definite order. A1, A2, A3, A4, all the way to AN. The number A sub 1 is called the first term. A sub 2 is the second term. In general, A sub n, the nth term. We will deal exclusively with infinite sequences, and so each term A sub n will have a successor A sub n plus 1. Notice that for every positive integer n, there is a corresponding number A sub n. And so a sequence can be defined as a function whose domain is a set of positive integers. But we usually write A sub n instead of the function notation f of n for the value of the function at the number n. Notation: the sequence open bracket 1 A sub 1 A sub 2 A sub 3 ellipsis close bracket is also denoted by open bracket A sub n close or open bracket A sub n close bracket n 2 equals 1 to infinity.